Now that we are familiar with the list of basic identities and we know how to simplify trigonometric expressions algebraically, we can now proceed to the all-important skill in trigonometry of verifying identities. In this class, when we verify or prove an identity, we're going to use the two-column format. I'll demonstrate this to you on example 1 when we verify an algebraic identity. The equation we want to verify here is x times x plus 1 squared equals x cubed plus 2x squared plus x. So I'm going to choose one side of that identity equation, and I'm going to start with the left side. I'm going to copy that down in one column, and then I'm going to show step by step that the left side can be transformed into the right side using properties of algebra. So to begin with, I'm going to rewrite that squared binomial as the product of two identical binomials. Then I'm going to use the FOIL process to multiply those two binomials. Then I'm going to distribute the x to get x cubed plus 2x squared plus x. Based on this string of equal signs, we can see that we've taken the expression on the left and transformed it step by step into equivalent expressions until it's finally equal to the original expression on the right side. Thus, we have verified the identity. Now, notice the organization of this proof. We've got a column on the left and we have a column on the right. This is what's known as the two-column format. Let's try this approach with verifying a trigonometric identity here in example 2. So to verify the given identity, I'm going to begin with the expression on the left. Now, the reason I'm beginning with the expression on the left for this identity is because there's a pending operation. So there's some obvious first step that I can take in order to transform the left side into the right side. So I'm going to FOIL the left side and see what happens. So the product of the first two terms is sine squared of x. The outside terms have a product of negative sine of x. The inside terms have a product of positive sine of x. And the last terms have a product of negative 1. Now we can see that the two middle terms cancel, and the resulting expression is sine squared of x minus 1. Now, I've carried out the pending operations and simplified, but remember, my goal is to show that this is equal to negative cosine squared of x. So I'm going to refer to our fundamental Pythagorean identity. This one's very popular. It shows up in all kinds of problems. And my goal is to rewrite sine squared of x in terms of cosine squared of x. I can do that by solving this fundamental identity for sine squared of x. And that is, we subtract cosine squared of x from both sides. So I'm going to replace sine squared of x with its equivalent expression, 1 minus cosine squared of x. So replacing sine squared of x, we have 1 minus cosine squared of x minus 1. Noticing that the 1's cancel, we end up with the expression negative cosine squared of x. And that was our original right side. So by starting with the expression on the left side of the original identity and showing step by step through this string of equals that we can transform it into the expression on the right side, we have verified the identity. And again, do notice the two-column format. I have one expression in the first column, and I've showed step by step that it can be transferred into the expression on the right column. Now, the goal in verifying an identity is not necessarily to find the simplest form. The goal is to show that one side of the identity can be transformed into the expression on the other side. Now, as we verify identities, there are a few things that can be helpful. So let's talk about some tips to keep in mind. Keep the following guidelines in mind when verifying trigonometric identities. Number one, it's usually easiest to start with the most complicated expression. In example 2, we started with the expression that had a pending operation that we could execute. That was more complicated than what we had on the right side. If I had started this proof with what's on the right side, I would have had to have been much more creative to show how it can be transformed into the left side, though it could certainly be done. Number 2, keep the expression on the other side of the equation as your goal. Remember, you're not trying to find necessarily the simplest form of the most complicated expression. You're trying to show that it's equivalent to the expression on the right side. Number 3, use common identities to transform the expression on one side of the equation into the expression on the other side. For example, when we did problem 2, we used a fundamental Pythagorean identity in order to find an equivalent expression for sine squared of x. And number 4, this one is very important, show every step. The goal is to construct a proof, not race to an answer. Now, I know that there's many of you out there that are sharp with your arithmetic, and you can calculate things mentally lightning fast, much faster than I can. But that's not the point of constructing a proof. When we construct a proof, we're demonstrating the logic, outlining the steps of how one side can be transformed into the other side. So the point is to demonstrate the steps, not necessarily race to the answer. So I hope those tips are helpful. Keep these in mind as you begin constructing your 2-column identity proofs.